We're now going to walk through some examples where we're going to use part 1 of the Fundamental Theorem of Calculus to find the derivative of the given function. Just to make things easier, I have written down the essence of the Fundamental Theorem of Calculus here in this green box. The Fundamental Theorem of Calculus tells us that if g of x is the integral from a to x of f of t dt, then dg dx, or g prime of x, is equal to f of x. Let's now look at our first example. We want to find g prime of x, and the Fundamental Theorem of Calculus tells us that the derivative of g of x with respect to the upper limit x is the integrand, which is the quantity 2 plus t to the 4th raised to the 5th power, evaluated at the upper limit x. So this is just 2 plus x to the 4th raised to the 5th. And we'll go ahead and highlight that. Now let's look at our second example. Notice in this example that the variable x is in the lower limit. To use the Fundamental Theorem of Calculus, the variable needs to be in the upper limit. So we are going to start by changing the limits of integration and writing g of x as minus the integral from 4 to x t squared sine t dt. Remember that when you switch the limits of integration, all you do is multiply by a negative. Now we can go ahead and find the derivative of g of x by using the Fundamental Theorem of Calculus. We have g prime of x is equal to the integrand t squared sine t evaluated at our upper limit x. So we have our negative, and now we're going to have x squared sine x. And there's our answer. Let's now look at example 3. This example is different than the first two because in the upper limit, we have 1 minus 3x. So it is not a single variable. We can only use the Fundamental Theorem of Calculus part 1 to find a derivative if we have a single variable in the upper limit of integration. So what we're going to do is we're going to let u be equal to 1 minus 3x. So g of x is now g of u of x. The integral from 1 to u of t cubed, all divided by 1 plus t squared dt. If you're thinking, I think I've done something like this before, think about the chain rule. That's exactly what we're going to use to find the derivative. The chain rule tells us that dg dx, when g is a function of u, which is a function of x, is equal to dg du times du dx. Let's see what this gives us. Let's look at dg du first. That is just the derivative of this function right here with respect to u. And now u is our upper limit of integration. So dg du is just this integrand evaluated at u. So this gives us u cubed, all divided by 1 plus u squared. Now we have to think about du dx. U is given right here. So du dx is just the derivative with respect to x of 1 minus 3x. This gives us u cubed all over 1 plus u squared times this derivative, which is equal to minus 3. Now, we're not quite done. We need to put our answer back in terms of x. So we're going to use this value of u and plug it into our answer. This gives us the quantity 1 minus 3x cubed, all divided by 1 plus 1 minus 3x quantity squared times minus 3. And let's rewrite this as minus 3 times 1 minus 3x quantity cubed, all divided by 1 plus 1 minus 3x quantity squared. And there's our final answer. I think this problem was the hardest one, so you may want to go back and see if you can work this one on your own.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.